9702 October, November 2015, paper 2, grade 1. The topic is projectile motion and the question number is 3. An object moves from point P to point R either by a direct path or the path P to Q to R. P and Q are on the same horizontal level and R is the vertical above Q. Explain whether the work done moving the object against the gravitational field is the same or different along the path PR and PQR. So first of all, we need to realize that from P to Q there is no work done. Why? Because the work done is against the displacement and the force is actually the gravitational force and it is always downward and the body is moving horizontal, which is perpendicular. So no work is done against the gravitational field from P to Q. The only work done is from Q to R. Same goes here if the body moves from P to R, so the only the vertical component of the weight will act. So the work done from P to R and Q to R is the same, right? PQR provide this thing explains that PQQ has no work done. So work done is the same for both paths. Work done P to Q is zero because the displacement is not in the direction of force. Work done from Q to R same as work done P to R, right? Because the P to R has what the only the vertical component of the weight will provide the work and Q to R, which is Q to R. So the work done from Q to R is same as the work done P to R, right? A ball is thrown with an initial velocity v at an angle theta to the horizontal axis. So this is the graph of height versus time, and you see the maximum height it gains is 11 meter, and the time is 1.5 seconds. Here resistance is negligible. Now use the time to reach the maximum height to determine the vertical component Vy of the velocity of the ball for time t equals to 0. Now we have two equations to solve that. One is second equation motion, which is h ut half gt square, and second is the simple explanation. The first equation motion, which is v minus v equals ug v minus u plus gt, or a equals v minus u over t. So h is equal to ut plus half gt square. H is 11. V initial velocity is vy. Time is 1.5. 1 upon 2. G is 9.8 and G is moving up, body is moving upwards, so G is minus, right? 1.5 square. So after solving this, we will get U equals 14.68, which is approximately 15 meter per second square. Now using this, minus 9.81 equals 0 minus Vy over 1.5. So after resolving, we will again get 15 meter per second. 15 meter per second, 15 meter. The horizontal displacement of the ball at t equals 3 is 25.5. On the figure, draw the variation with t with the horizontal displacement right of the ball. So h is 11, 10, t is 1.5. So Vx over t is 1.5, but here is t is total 3 second. T is total 3 second, and h is not. We can remove this because it is for other purpose. So yes, Vx is equals to S upon T. So Vx equals 25.5 upon 3. So Vx is equals to 8.5 meter is 8.5 meter per second. Now, for the ball at the maximum height, calculate the ratio. Potential energy of the ball, kinetic energy of the ball. You know, the potential energy is engaged when the kinetic energy is only the horizontal component will act because vertical component at maximum height of the velocity is zero, right? So mgh over half mv square, gh over bx square, right? Because Vy at the maximum height is zero. So 92 into 9.81 into 11 over 19.5 is equals to 2.98, which is approximately 3, right? So yes. In practice, the air resistance is not negligible. State and explain the effect of air resistance on the time taken for the ball to reach the maximum. We know when the ball reaches to the maximum height, now air resistance is there. That means A is not equal to G anymore, right? So the gravitational force which is downward, is now there is a air resistance force which is moving upward, which is against the motion. So that means the acceleration is becomes deceleration, and this deceleration is very much less than G, right? And the net force of reduced initial cases will not be paid. That is why, because we have the net force again. Net force is equal to weight minus the air resistant force. So this, due to this net force, the ball will not reach to the maximum height as it is previous one. So that means at the for the maximum height with the air resistance is very much shorter than the previous height. So if the height is shorter, that means the time taken to reach that smaller height comparatively before will be less. So net force is greater than the weight. Reduced deceleration, ball will not attain the maximum height as previous. So the time taken will be lesser than the previous.